A current carrying wire produces a magnetic field of 2 times 10 to the power of negative 6 Tesla, measured 10 centimeter from the wire. What current must the wire be carrying to produce that field? As you know, when we are dealing with a wire that is carrying electric current, it can be this way or that way, doesn't matter, doesn't change the strength of the magnetic field, it just changes the direction, which we can use right hand rule to find out. So for electric current, it's going to produce magnetic field. How do we find out magnetic field? What is the relationship between electric current and magnetic field? We need to use the formula called Ampere's law. B, which is magnetic field strength, equals to mu naught times I divided by 2 pi r. Mu naught is the constant, which is 4 pi times 10 to the power of negative 7. I is the electric current in terms of ampere, and R is the distance from wire in terms of meters. So in this case, B is given, which is 2 times 10 to the power of negative 6 Tesla. R is given, which is the distance from wire with 10 centimeter. Don't forget that you need to convert it to meters. So 10 divided by 100 is going to be 0.1 meters. Then you can find easily the I, which is electric current. So when you do the cross multiplication, I will be equal to 2 pi r times B divided by mu naught. So it's going to be 2 pi times R is 0.1, B is 2 times 10 to the power of negative 6 divided by 4 pi times 10 to the power of negative 7. Let's solve it without using a calculator. So pi and pi cancel out. 2 times 2 is going to be 4, so then it cancel out with the 4 in the denominator. 0.1 times 10 to the power of negative 6 is going to be 10 to the power of negative 7. Divided by 10 to the power of negative 7, obviously is going to be 1, because when you have a number divided by the same thing, that's going to give us 1. So I, electric current, is 1 ampere. So that's how we calculate the electric current from magnetic field strength and the distance from the wire.